Following the previous class on the discussion of simple microscope, this session focuses on compound microscope. The simple microscope, as you know, it magnifies the image 10 times by using only one lens, whereas the compound microscope magnifies the image 100 times, even up to 1000 times. It has a high magnifying power as well as resolution power. Due to this, it is essential for the study of microstructures of cells and bacteria. It finds application over there. This diagram gives the construction and working of compound microscope. It has two lenses. It is objective lens, here designated as O. It is called as eyepiece lens, designated as E symbol. And this lens has a focal length of f0. It is the distance between these 2 points, these 2 points or these 2 points. And this is the focal length of this lens. It is the distance between these 2 points or these 2 points, focal length. This focal length is higher than this focal length. In the microscope, this objective lens is mounted to the rotating nose, which carries about 3 to 5 lenses like this. Lenses of different magnifying power, but only one at a time can be used. Objective lens, and this is always a fixed one. In this compound microscope, this is the object under study. The object is placed behind the focal length of the lens f0. It is behind this point, focal length. If that is the case, the light rays converge to produce the image like this. On the other side, that is the inverted and of course magnified inverted image. In the previous class, in the simple microscope, the object was kept within the focal length of the lens, where the light rays undergo diverge to produce image on the same side, that is virtual image on the same side in the previous class. This is the reverse. We get the image like this. And the formation of image is like that, such that it lies within the focal length of the second lens, that is between these 2 points. The image forms between these 2 points, within this. This is the first image by this lens, but this becomes an object for the second lens as well as. It is known as virtual object, this image, virtual object for this lens. And this object is within the focal length, produces what is that? Rays, light rays diverge like this. And diverging point here, the same side. Inverted, you get inverted only. The image is further magnified like this because of divergence. This is second image by this lens. This becomes the object for this lens. This is the procedure or the working of the compound microscope. In this microscope, using this diagram, we need to derive the expression for, that is, magnification of compound microscope. The equation for magnification, just recall that, use a similar definition. M equals the ratio of these two angles theta I divided by theta naught. What is theta I? It is the angle by the final image, that is a magnified image, angle subtended by this height of the image at the I is looking to this I, that angle is theta I. This is the angle subtended, it is a theta I. Angle subtended by the image, that is final image, the height of the image at the I, it is called theta I, that is the theta I. Then what is theta naught? Theta naught is, this is the one, the same object. Here I have second same height of the object here, and it is without lens or without microscope, direct view. So in this case, it is the angle subtended at the I, same object due to this object, height of the object. Due to height of the object, it is theta naught. And it is a minimum distance for a view. At least the object should be at this distance, a near point, 25 centimeter, as you know, comfortable for view. So D is the distance. Using this diagram, we can write what is that? Theta, that is theta naught. Theta naught equals h divided by d. Opposite side divided by adjacent side. Since you are taking tangent of this angle, tangent of this angle is same, that is theta I. Tangent of this angle is theta naught, because the angles are very small due to microscopic size. That is what written. Theta I is equal to, you can define this theta I in this diagram, that is from the figure 1. This right angle triangle I am taking this. Theta I equals opposite divided by adjacent side. That is the height of the image 1, h1. It is the distance of the virtual object for this lens. It is uv. hi by uv. I am taking this triangle suitable for this because this is measurable. Theta I, that is the angle subtended by the image at the eye through the microscope. Here angle subtended at the eye by this only height of the object, no magnification. That is h by d. Tangent of this is h by d, or theta naught equals h by d. This is how we have get this. Theta naught equals h by d, and theta I equals h by u. From the, it is from the figure 1, it is from the figure 2. Now let us find out what is h1. The expression for h1 from the definition of magnification of object lens. We have defined either in terms of height and distances. Height of images, distance of image. It is by the object lens. It is the height of the image, it is the height of the object. h1 divided by h. And along with sign, minus because of it is inverted, it is upright plus. In terms of distances, image distance, here v0 is the image distance for this lens and u0 is the object distance for this lens. Sign convention, it becomes plus, it becomes minus. And minus cancels. What is the remaining? hi equals cross multiply. You get the expression for h1 like this. This is to get expression for h1 using this definition. And put this expression into this equation 2. We get like this. Divide by this is this. This is the equation for q1, qi, this is the equation for q0. Put them into equation 1 to get the expression for magnification. Numerator, denominator. HH cancels, D goes to numerator, V0 D divided by U0 D. This is the final equation, an expression for magnification by compound microscope. Magnification. And see that in this equation, there are two definitions, that is, this ratio is known as magnification by the object lens. magnification by the object lens. This ratio is called as magnification by the eyepiece lens. Here, distance of image to distance of object. Distance of image and distance of object in the eyepiece. This distance d is same as distance of image VE. I have taken the minimum distance. So you can write this as m naught into me. This is m naught. This is me. So magnification is overall product of magnification by the object lens and magnification by the eyepiece lens. The expression separately written like this. Magnification. If this is the equation, let us verify this equation for two different values. Because what would be the possible length of image, possible distance of image from this lens, possible distance of image from this lens for a comfortable view. It is of course a range between two values. One is a minimum value, other is a maximum, least value or highest value. The least value is d and highest value is infinity. In this range, the image is comfortable. Let us find out what is the equation for this condition, what is the equation for this condition. Apply the same thing, but this will remain same, only this will go undergo alteration. So taking d by uv is a me, and let us apply this to this using this equation for lens. This is well known. You write this equation for eyepiece, only for this eyepiece lens. That is always positive. And v equals d. Let us write v equals d for this. But d is minus in this direction. Same convention. And uv is uv only, but direction is in this direction. uv minus uv. This sign convention. And simplify, it becomes plus minus. This becomes, we take 1 by uv is equal to this expression we get. Substitute for 1 by uv into this equation. D into 1 by u. Simplify, get 1 plus d into fe. That is expression for me. So overall expression is m equals m naught into 1 plus d by fe. This is the expression for magnification by the compound microscope. When the image distance is at near point, it is d. And let us check for the image at infinity. Apply the same equation. This is equation for eyepiece lens, and substitute for this. V is equal to infinity and uv is equal to minus uv. Simplify, it becomes 0, 1 by infinity. This becomes plus. It is same as this. So 1 by uv is equal to 1 by fe. Put that is, so 1 by uv, that is d by uv here. It becomes d by f, that is, into this equation get d by fe. It becomes d by fe. M into m naught into d by f. Look at this equation. Equation for the magnification by the compound microscope. It is depending on the that is magnification of the objective lens, and the wavelength, that is focal length of the second lens, eyepiece, inversely and directly. Here with this one addition. Here it also magnification, and the image is at distance d. Suppose if we get the image at infinity, m is equal to m naught remains same, d divided by fe. That is, d is constant. It also inversely to fe and directly to m naught. Higher the value, lower the value. Higher is the magnification power than the image at m naught. And in between the image, wherever it comes, it is visible. Accordingly, we can calculate what is the magnification power. So these are the two possible cases where the magnification for the compound lenses is given for the least value and the highest value of, that is image distance from the lens. So with this you have just completed this. Thank you.